Hi all. Today let us understand what is Kirchhoff's current law, that is KCL. So it says as the algebraic sum of currents entering a junction is equal to zero. So it is denoted like this: summation of I equal to zero. That is the mathematical expression. Now let me give you an example of what it actually says. One node is something like this: node, electrical node, where current is coming from different side. So let's say this is one side, this is another side, this is another side, this is another side. So let's say this is I1, this is I2, this is I3, this is I4. So what it is saying is that I1 plus I2 plus I3 plus I4 all equal to 0. Now look at this diagram. In this diagram, I1, I2 and I4 is into inward direction and I3 is outward direction. So algebraically, if we consider I1, the direction of I1, I2 and I4 positive, then the direction of I3 should be considered as negative. So we can correct the equation like this: I1 plus I2 plus minus of I3 plus I4 equal to 0. So this is Kirchhoff's current law. It can be expressed in little different way, little easier way, that the sum of currents entering any node in an electrical circuit is equal to the sum of currents leaving that node. What it means, again, if I go to the same diagram, this is the node and the current is coming from different direction, like this, like this, and one current is exiting, and this is I1, this is I2, this is I3, and this one is I4. So it is saying that I in means which is coming inside, that is I1 plus I2 plus I4, that is equal to I3. So if you look at both the equations, this one and this one, both are actually saying the same thing. So in both the way, you can represent this Kirchhoff's current law. Now let me show one practical example that can clear your understanding little more. Let's say this is a current source of 10 ampere and it is connected to a circuit. Let's say circuit have resistance at different level. So this is R1, this is R2, this is R3, and here it is R4. Now this is R2, this is R3, and this one is R4. So current through this branch is 10 ampere, but we don't know what is the current here. Let's assume I1. Let's assume this current as I2. Uh, this current, let's say it is given as 2 ampere, and this current, let's assume as I3, and then this current, let us assume as I4. Now, uh, see, there are, this is one node, this is one node, this is one node, and this is one node. We can create some equation using the Kirchhoff's current law. The first is, let's say this is node 1, this is node 2, this is node 3, and this is node 4. So from node 1 we can create this equation: 10 equal to I1 plus I2. From node 2 we can create the equation I1 equal to 2 plus I3. From node 3 we can create the equation that is 2 plus I3 equal to I4. And finally, from the node 4 we can create an equation like I4 equal to, is what, this one is I2 plus 10 ampere, right? I2 plus 10 ampere. So now look at this here is I1, I2, uh, I1, I2, I3, I4, right? There are four variables and there are four equations, right? This is equation 1, equation 2, equation 3, and then it is equation 4. So since there are four equation, we can find out the result, that is the value of I1, I2, I3, and I4. That is how we can solve the mm, I mean, we can do this analysis of circuits using Kirchhoff's current law. Okay, I hope this has cleared your doubt. Thank you.